Ashe. My dear friends, I am your royal narrator, Queen Magical Melanin, extending a warm greeting to all gathered for our basic applied electronics information session produced by our esteemed elder Baba Jelani Bomani Dembe, the brilliant mind behind Majestic Mind Matters University and the mandatory Mental Liberation series, eagerly enriching our learning journey. Today, we venture into the world of basic applied electronics, where circuits and currents intertwine to unlock endless possibilities. Let us embark on this enlightening adventure together, exploring the wonders of technology and innovation under the guidance of our distinguished elder Baba Jelani Bomani Dembe. Welcome to a transformative experience that will ignite your curiosity and mastery in the field of applied electronics. Each moment you spend with us is a gift, a chance to grow, to learn, to be inspired. So stay with us till the end, where the true magic happens. Pay close attention and take plenty of notes to prepare you for possibly answering a few easy questions near the end of the session. Introduction to the infrared emitter and the detector. Infrared emitters and detectors are essential components in many electronic devices and systems. They are used in a wide range of applications, from remote controls for TVs and other consumer electronics to security systems, night vision cameras, and medical devices. Applied electronics technicians need to have a good understanding of how these components work and how they can be effectively integrated into electronic circuits. Infrared emitters are semiconductor devices that emit light in the infrared spectrum when an electric current is passed through them. They are often made from materials such as gallium arsenide or gallium nitride, which have the necessary properties to emit infrared light efficiently. The wavelength of the emitted light can vary depending on the material and design of the emitter, but most infrared emitters used in electronics emit light in the 700 nanometers to 1000 nanometers range. Infrared detectors, on the other hand, are devices that detect infrared light and convert it into an electrical signal. They are often made from materials such as mercury-cadmium telluride, indium antimonide, or lead sulfide, which have the ability to absorb infrared light and generate an electrical current. The sensitivity and response time of an infrared detector depend on factors such as the material used, the design of the detector, and the wavelength of the infrared light being detected. One important concept that applied electronics technicians need to be familiar with when working with infrared emitters and detectors is the principle of modulation. Modulation is the process of varying a signal in a controlled way to encode information. In the case of infrared communication systems, modulation is used to encode data onto the infrared light emitted by an infrared emitter. This data can then be decoded by an infrared detector to retrieve the original information. There are several different modulation techniques that can be used in infrared communication systems, including amplitude modulation, AM, frequency modulation, FM, and pulse width modulation, PWM. Each of these techniques has its own advantages and disadvantages, and the choice of modulation technique will depend on the specific requirements of the system being designed. Another important consideration when working with infrared emitters and detectors is the range and sensitivity of the components. The range of an infrared emitter and detector system is determined by factors such as the power of the emitter, the sensitivity of the detector, and the ambient light conditions. For long-range communication systems, high-power emitters and highly sensitive detectors may be required to ensure reliable communication over a wide distance. In addition to range and sensitivity, applied electronics technicians also need to consider factors such as line of sight and interference when designing systems that use infrared emitters and detectors. Infrared light is directional and can be easily blocked by obstacles in the path of the emitter and detector. To ensure reliable communication, technicians may need to use reflectors or lenses to focus the emitted light and enhance the detection signal. Interference from ambient light sources, such as sunlight or artificial lighting, can also affect the performance of infrared communication systems. To minimize interference, technicians may need to use filters or shielding to block out unwanted light sources and improve the signal-to-noise ratio of the system. Infrared emitters and detectors are versatile components that are widely used in electronic devices and systems. Applied electronics technicians need to have a good understanding of how these components work, including their modulation techniques, range and sensitivity, and potential sources of interference. By mastering these concepts, technicians can design and implement effective infrared communication systems for a wide range of applications. Applied electronics technicians need to have a good understanding of infrared emitters and detectors in order to effectively design, troubleshoot, and repair electronic devices that utilize infrared technology. These components are essential for a wide range of applications, from remote controls and security systems to medical devices and communication systems. One important aspect that technicians need to understand is the characteristics of infrared radiation and how it differs from visible light. Infrared radiation has a longer wavelength than visible light, which allows it to penetrate certain materials and be detected by infrared detectors even in low light conditions. This makes it an ideal choice for applications where visibility or line of sight is limited, such as in wireless communication or motion sensing. Technicians also need to be familiar with the different types of infrared emitters and detectors available and their respective operating principles. For example, thermopiles are passive infrared detectors that generate a voltage output proportional to the temperature difference between the detector and the object emitting infrared radiation. Photodiodes, on the other hand, are semiconductor devices that produce a current when exposed to infrared radiation, while pyroelectric detectors generate a voltage in response to changes in temperature caused by infrared radiation. In addition, technicians should be aware of the factors that can affect the performance of infrared emitters and detectors, such as temperature, ambient light, and interference from other sources of infrared radiation. For example, changes in temperature can affect the sensitivity and response time of infrared detectors, while ambient light can interfere with the detection of infrared signals. Proper calibration and alignment of infrared emitters and detectors is also critical for ensuring optimal performance. Technicians need to carefully set the operating parameters of these components, such as the current flowing through the emitter or the sensitivity of the detector, to ensure that they are functioning correctly and providing accurate data. Furthermore, technicians should be familiar with the different ways in which infrared technology is used in electronic devices. Infrared communication, for example, is commonly used in remote controls for TVs, air conditioners, and other appliances, as well as in wireless networking devices and security systems. Infrared sensors are used in motion detection systems for security and automation applications, as well as in medical devices for monitoring body temperature or detecting abnormal tissue growth. Overall, infrared emitters and detectors are essential components in electronic devices that utilize infrared technology for communication or sensing purposes. Applied electronics technicians need to have a solid understanding of how these components work, the various types available, and the factors that can affect their performance. By having this knowledge, technicians can effectively design, troubleshoot, and repair electronic devices that rely on infrared technology, ensuring that they function properly and reliably. Infrared emitters and detectors play a crucial role in a wide range of electronic devices and systems. Applied electronics technicians need to have a thorough understanding of these components in order to effectively design, troubleshoot, and repair such systems. In this essay, we will explore two common types of infrared detectors, thermopiles and photodiodes, and discuss what technicians need to know about them. Thermopiles are devices that consist of multiple thermocouples, which are pairs of dissimilar metals connected in series. When infrared radiation hits the thermopile, it causes a temperature differential between the two metals. This temperature difference creates a voltage across the thermocouples, which can be measured as an electrical signal. Thermopiles are commonly used for measuring temperature in various applications, such as in industrial processes, HVAC systems, and medical devices. Applied electronics technicians need to be familiar with the principles of operation of thermopiles in order to effectively calibrate and troubleshoot temperature measurement systems. They should understand how the voltage output of a thermopile is directly proportional to the temperature difference between the two metals and how this relationship can be used to accurately measure temperature. Technicians should also be aware of common issues that can affect the performance of thermopiles, such as electrical noise, thermal drift, and calibration errors, and know how to address them. Photodiodes are semiconductor devices that generate an electrical current when exposed to infrared radiation. When infrared radiation hits the photodiode, it creates electron-hole pairs within the semiconductor material. These electron-hole pairs flow as a current through the photodiode, generating an electrical signal proportional to the intensity of the infrared radiation. Photodiodes are commonly used in infrared detectors for a wide range of applications, including sensors, night vision devices, and communication systems. For technicians working with photodiodes, it is important to understand the operating principles of these devices and how they can be effectively integrated into electronic systems. Technicians should know how the electrical current generated by a photodiode is directly proportional to the intensity of the infrared radiation incident on the device, and how this relationship can be used to accurately detect and measure infrared light. They should also be familiar with the characteristics of different types of photodiodes, such as responsivity, quantum efficiency, and response time, and know how these parameters can affect the performance of infrared detectors. In conclusion, thermopiles and photodiodes are essential components in infrared detectors, and applied electronics technicians need to have a solid understanding of these devices in order to effectively work with them. By familiarizing themselves with the principles of operation of thermopiles and photodiodes, technicians can ensure the accurate measurement of temperature and the reliable detection of infrared radiation in a wide range of electronic systems. Additionally, technicians should be aware of common issues that can affect the performance of these devices and know how to troubleshoot and address them. By mastering the fundamentals of thermopiles and photodiodes, technicians can enhance their skills in working with infrared emitters and detectors and contribute to the successful operation of electronic systems in various industries. Thanks for your participation in this special Majestic Mind Matters University Basic Applied Electronics Information session. I am your royal narrator, Queen Magical Melanin. Here is a special message from our esteemed elder Baba Jelani Bomani Dambe, the brilliant mind behind Majestic Mind Matters University. To all applied electronic technicians, he wants you to know this. Your participation with Majestic Mind Matters University has been invaluable. Your expertise and commitment to excellence has elevated our research and knowledge in the field of applied electronics. Thank you for choosing Majestic Mind Matters University as a trusted source for your valuable applied electronics information to aid to your success with this basic applied electronics information session titled Introduction to the Infrared Emitter and the Detector. Stay woke. Ashe.